Hello, and welcome to another Space Weather Data Portal tutorial. Today I'll be doing something a little different, and I'll show you how to access and display our space weather datasets in a Python notebook. I'll walk you through the notebook here, and when we're done, there'll be a link to it in the video description, so you can play with it yourself. Now, the title of this notebook is Accessing and Displaying Space Weather Datasets with LaTiS, which begs the question, what is LaTiS? It's the name of the data access technology underlying the Space Weather Data Portal. It's what serves all of our space weather data on our website. This example notebook is split into two main parts, a section describing what LaTiS is and how to use it, then a section about using LaTiS to interact with our space weather datasets through Python code. I'll go through this first section pretty quickly, so feel free to pause the video if you want to read more than what I cover. Starting with the basics, we interact with LaTiS through its REST API using query URLs. This LaTiS usage box here shows the basic format of these URLs. The base URL is the entry point into the API, and for our Space Weather Data Portal, that'll always be this URL here. Note the LaTiS server is already running there, so you don't need to download anything to use it, just give it queries. After the last slash in the base URL, we specify what dataset we want, in what format, what variables we want from it. We can subset the data in various ways, and we can apply a number of convenient LaTiS operations to transform the data on the fly. We give you 4 example URLs here just to demonstrate how this works. And just stepping through the first one here, the base URL ends here. We're asking for the Kyoto DST index dataset as a CSV file, keeping only the time and DST variables. If you omit this projection, you just get every variable in the data set. We're only looking at data before 2005, and we're limiting the results to the first 10 rows of data. For a list of every data set available to you, you can follow this link to a LaTiS landing page that lists them. We offer a variety of output formats beyond just CSV, and we list them all here. And we show you some of the LaTiS operations available to you here. You can do things like reformat timestamp values, filter results by dropping certain samples, maybe keep only the first sample, etc. And a number of other convenient things like renaming variables and replacing missing values. So yeah, that's how LaTiS works. Let's write some Python code and play with some data, shall we? We'll use 3 packages for this: pandas to store and manipulate data in a convenient data structure, requests to work with raw data files, and matplotlib to plot things. Now remember the structure of our LaTiS query URLs. We could type them out by hand each time if we wanted, but to save some time, I'm going to use this little LaTiS query URL helper function I wrote to generate the URLs for us. So the way I did it, all we'll do is pass in the things we want, like the data set, the output format, and whatnot, and this function will give us the correct query URL. The most basic thing we can do is read some space weather data into a pandas data frame. To do that, we throw query URLs at the pandas read CSV function. Let's get the data from that first example URL we looked at a moment ago. That URL was this. To get the data, we do pandas.read CSV and give it our query, tell it which column is the time column to index the data frame, and then we can print the data. And here they are, the first 10 rows of Kyoto DST index data before 2005. But I don't want to keep writing out these full URLs, so I'll replace it with the equivalent call to my little helper function now. And we get the same output. And if we want a different data set, just ask for it. Like if we want ACE magnetic field data, its identifier is this. Remember, there's a LaTiS landing page that'll give you all these dataset identifiers. Just replace Kyoto with that, and whoops, I forgot to remove this projection. Let me do that real quick so we get all its variables. Rerun it. And voila. Pandas is great if you want to use your data right there in your code, but some workflows require files instead. We can get space weather data files with Python's built-in requests library. And this is where a powerful feature of LaTiS shines. We can get data in a variety of file formats, regardless of the format the data is stored in at its source. Let's get Kyoto data as a JSON arrays file instead of a CSV this time. We do requests.get and give it our query. And then we write the data to a file. Now, when we run this, we get this Kyoto.json file in our current directory. Open it. And here's our data. So we've seen how to get the data we want. Let's talk a little about manipulating the data. We have a few options, but they basically boil down to a choice between using server-side LaTiS operations before you download it, or doing it in a data structure after the download. This section of the notebook looks at 3 different ways to perform 3 example tasks: getting all the values of a single variable, getting the first row of a data set, and getting the last 5 rows of one. The notebook shows how to perform these tasks with LaTiS and data structure manipulations, but I'm only going to talk about the LaTiS methods because the others are specific to how you slice a pandas data frame in general. Plus, not only are the LaTiS operations the simplest option in each example, they also save network bandwidth because the other methods require downloading more data than you end up keeping. We get the values for a single variable by projecting only that variable. So if we want only the long wave values from goes 15, we build a query URL asking for that data set, and we simply include the projection long wave. Now, this query will get us all of the long wave values, but that's a lot of data. So to save time in this notebook here, I'm going to give it upper lower time bounds. We read the query with pandas read CSV, and when we run that, there's our long wave values. To get the first row of a data set, LaTiS has a simple first operation. Getting the first row of goes 15 data looks just like above, except instead of projecting, we'll put this first operation in the query URL. Boom. This is great for peeking at the data without triggering a large download. Getting the last rows of a data set can be a hard thing to do efficiently because in many cases it requires you to download or stream through the whole data set, but then only keep the last few bits of data, which is wasteful. LaTiS offers a convenient take-write operation for this purpose. I'll encourage you to look through the operation options section back at the top of this notebook because there are plenty of operations that do useful stuff beyond subsetting your data. Filling missing values is a good one because a lot of programs don't like nans. We can do that one with the replace missing operation. Note our missing values here. And a super common one is to reformat timestamps to a certain style, like ISO 8601 strings, for example. We do this with the format time operation, and you see the formatted timestamps here. Moving on, the last thing to talk about is plotting data we get from the space weather data portal. There's actually not a lot that needs to be said, though, because we can get our data in a pandas data frame, and pandas has a simple plot function that we can just call. Just data.plot. It's literally that simple. Their plot function is a wrapper around matplotlib code, and it accepts a variety of arguments to customize the plot. But if you want more control over your plot, you can use matplotlib directly. The equivalent code to produce the above plot would be this. Finally, the last thing I'll show off in this notebook is plotting image datasets. The Space Weather Data Portal offers image datasets that are time-stamped URLs to images, and we can write code to open these images and display them. The SWT B field maps is one such example. We'll use matplotlib's mp image, numpy, pill, and URL lib to do this. We make our query. We'll get just a list of the URLs by projecting the URL variable and then pulling that variable out of the data frame as a list. Then for every URL in that list, we're going to open the URL, open the image using pill, and then make a numpy array out of that. There's the matplotlib code to produce the plot, and we let it run. Ta-da! And that's it. I hope you found this tutorial useful. Remember to follow the link in the description to get this notebook in your browser and play with it for yourself. And please feel free to contact us if you have any questions. Thank you.